Let's talk about domain and range of a function. The hope is that by the end of this video, you will be able to define what domain and range are in a set of data. And we are going to discover this by means of a bar graph. You may not have seen these in a while, but I know you've all made them. So for our bar graph, we're looking at the monthly snowfall in Buffalo, New York. Buffalo, my hometown, where in fact it snowed 9 inches a couple days ago. 29th of March, it snowed 9 inches, and down here we've got the dogwoods about to come out. We've got the cherry blossoms. It's been spring for a couple weeks. I love the snow. I love playing in it all winter long, but it gets old by the time you get to March and it's still muddy and snowy. So let's check out our different months and our snowfall, and let's label our graph. Let's use one column for each month. So we have October, November, December, January, February, and March. And on the that'll be the x-axis. On the y-axis, we will put the snowfall in inches. So I will do that in green. Let's do that. Let's go 10 inches per bar. So 10, 20, 30, 40, 50, and our highest value is February at 54, so we'll stop at 60 right there. All right, now let's make our bars. So in October, we get 9 inches, so make our bar just about to 10. November, we're at 20. So there's November right at 20 inches, exactly right there. December, we jump all the way up to 37, so almost 40, not quite. So we'll fill in that bar. In January, we will go to 53, so not quite to 55, not quite halfway. Well, I've been in Buffalo. The largest snowfall I've ever seen was about 5 feet. So you do the math. How many inches would that be? Yeah, that'd be right around 60 inches, 12 inches per foot. And that was over Christmas break a couple years ago. It was unbelievable. We were digging out. My dog out in the backyard was just a bump running under the snow. February was at 54. We'll fill that in just a little bit higher than January. And then in March, we're back to 37, which is actually the same amount we got for December. If you add that up, that is a lot of snowfall right there. So there's our bar graph, and there's our data. And now this graph has some meaning. We can immediately choose a month. I could say, so what about December? What was the snowfall in December? And that's kind of like the input of our function. So we say our input data is December. I give you December, and you tell me, oh, it's about 37 inches of snow that you could expect. And if you think about it, which causes the other? Does our snowfall cause it to be a certain month? Or does the month that we're in kind of dictate what kind of snowfall we should expect? And if you think about it with weather, the month of the year is tied to the weather cycles. That's going to dictate how much snowfall we can expect. I mean, yes, you could be given the data for snowfall and probably guess about the month that we're in, but it's the season of the year that is kind of our input, and the output would be snowfall. So if I give you November, you could tell me, hey, we're going to have about 20 inches of snowfall. So what is domain? What is range of a function? Well, domain, as the words I've been using, that is the input values. So domain is the inputs of a function. And a function is a set of data. And usually they correspond, or they correspond in some way, and one will be dependent on the other. So the domain is the inputs, those are the inputs of the function, and we would call those the independent variables, or the independent axis. So the independent variable. Independent because the month dictates the snowfall and not the other way around. The month is going to be the month, and the snowfall will depend on that. We could also say that since it's on the x-axis, that it is the x values. The domain is the x values. So that's domain. Domain is our x values. It's our inputs. It's independent. It happens, and we have a resultant output. So for our range would be the outputs. The outputs of a function. In this case, our function compares the month of the year, or time in months, to the amount of snowfall you can expect in Buffalo, New York. So since it depends on the month of the year, then it is the dependent variable. Dependent. And you can just ask yourself, which depends on the other? The snowfall depends on the month of the year, so dependent variable. And finally, it would be the y values. So if we were going to write these as corresponding pairs as a solution, almost like from the graphs we've been looking at, x and y values, what could we expect? Well, let's go for October. Since we have x values and y values, it's just like writing a point on a graph, except instead of an x value, our input, because our independent variables are our inputs, those are x values. These are months, so we have October, and the y value, the output we expect for October, is 9. So that would be a way to write this as a corresponding pair. November, we could write as, for November, the input would be November, obviously, and then the output we could expect would be 20 inches of snow. And we could repeat that for all the other inputs. Now we'll get into what functions are later, and we'll see that for functions, for every input, there can only be one output. Or there can be, each input will map to a singular output, not two different ones. But you could have two inputs that map to the same output. So for example, December and March, you notice they both have 37 inches. But we don't have December mapping to 37 and to 53. There's only one output per input. So we'll look at that later, but that is an intro to domain and range, and you are now set up to try some of the bar graphs in your work. So make sure you check out the Google form, the questions, and we will catch you soon.